So these are past paper questions of Cape Math from 1998 coming up. All right. So here this question says solve the equation for x such that log to base 10 of x minus 4 is equal to 1 plus log to base 10 of x over 2. Now, how do you think we would go about solving this equation?
Sir, log to base 10 x minus 4. So would that be one equation? That x minus 4 is one value.
Yeah.
So we'd have to start working with log to base 10 of x over 2. Since it's a fraction, and we can separate it by saying log to base 10 of x minus log to base 10 of 2.
All right, we can do that, but why would you do that?
Sir, because that's... Okay, so would we distribute log to base 10 across x minus 4?
All right, so there are two ways we can do this. We're trying to solve for x, right? But notice with this equation, we have logs right here, we have log right here, we have a number right here. So in order to solve a log equation, we need all of the log info on one side and the numbers on the other side, don't it?
Yes, sir.
Yeah, so let's bring over this now. So let's subtract log to base 10 of x over 2 on both sides. And so what we would get is, well, log to base 10 of x minus 4. So log to base 10 of x minus 4. And then we subtract log to base 10 of x over 2. So we subtract log to base 10 of x over 2. And that's just equal 1, right?
Yes, sir.
Nice. Now, after we do that now, what do we know about when the bases are the same and we're subtracting log a minus log b? What's that equal to?
Log a over b.
This part right here is log a over b. So we can rewrite this now as log to base 10 of a over b. So it's going to be log to base 10 of x minus 4 over x over 2. X minus 4 over x over 2. X divided by 2. And that's equal to 1. Now let's simplify in this bracket right here. If we have x minus 4 divided by x minus 2, I'm gonna write that up a little bit up here. All right. Now if we have x minus 4 and we're going to be dividing it by x minus 2, it's the same as x minus 4 multiplied by 2 over x, right?
Yes, sir.
Nice. And so we can rewrite this part right here as 2x minus 8 over x. So let's rewrite this now as log to base 10 of, in here is really now 2x, because this is now 2x minus 8 over x. Now, what do you think we can do now to solve this equation?
So you can separate them now?
We need to separate them now. What's the definition of log?
Sir, a log is a base raised to a power.
Nice.
Or a number raised to a power. To give.
Yes. So the log of a base of a number, the result gives us a power. And then what does this information give us? It tells us that the number is equal to base to the power, right?
Yes, sir.
Nice. So look right here now, we have the base, we have the power, and we have the number. So we can set up that equation now. So what would that equation be?
2x minus 8 over x
Yeah.
raised to the power of 1.
So 2x minus 8 over x, not raised to the power of 1, is now equal to, here's the rule again. What's it now equal to?
10 raised to the power of 1.
Very good, 10 raised to the power of 1. That's why it's important, it's imperative we remember the definition of a log. All right, so I used up too much space, so we'll have to do a little squinging. So now, right here, now we can just go ahead and cross multiply, right?
Yes, sir.
So I'm gonna kind of just take off the x right here, just so we don't have much space. So I'm gonna write that 2x minus 8, 2x minus 8 is equal to 10x. It's fair if I write that?
Yes, sir.
Nice, so 2x minus 8 is equal to 10x. And so we can bring over now the 2x over here. Like, let's just bring over the 2x over here to get this part becomes now, bring the 2x over here. That's 10x minus 2x, that's 8x. And so we have 8x. And we bring
negative 8.
And we bring over, yes, this is 8x equal negative 8. And so what we're getting is
X is equal to negative 1.
x is equal to negative 1. That's the solution. X is equal to negative 1. There's an alternate method we could have used to solve this equation. All right, you want to see the alternate method?
Yes, sir.
All right, now let's see where we could do the alternate method. Let's try to make some space at the top up here. All right, now to do it alternately, what we could do is 1, we could rewrite 1 as log to base 10 of 10, don't it?
Sir.
I'm saying that we can rewrite 1 as log to base 10 of 10.
Yes, sir.
Using the rules of log. So nice. So we can write that this is now the log of x minus 4. When I just write the log of, this is base 10. So this can be written as the log of x minus 4. And that's equal to log 10 plus log x over 2. Now, when we have the log of x minus 4 is equal to the log 10 plus the log of x over 2, what we can then do is combine what's on the right-hand side to be one log, right?
Yes, sir.
When we combine it, it's just the log of 10 times x over 2 is what?
10x over 2?
Yeah. 10x over 2, and that simplifies to just be 5x, right?
Yes, sir.
Nice. So we have the log of 5. Then now we have the log of 5x is equal to the log of x minus 4. Now if log A is equal to log B, what can we conclude?
A is equal to B.
A is equal to B. Wonderful. And so what we're saying then is x minus 4 is equal to 5x, right?
Yes, sir.
Nice. So now we can bring the 5x over here and bring the minus 4 over here. So bring over the 5x, so we get minus 4x is equal to 4. So we get minus 4x equal 4. And so we get back our x equal?
Negative 1.
Very good. So from that, we get back our x being negative 1. So which method you preferred?
The second one.
This one?
Yes, sir.
Because it's shorter, right?
Yes, sir.
I understand. All right. No worries. And it's less tedious. But either way, that's how we do that. So this question was from 2008 or something like that. And it was worth 5 marks. 5 marks on the paper too. Right? Now here's another log question. It says, this question now was worth 6. And this was, I think, from 2009 or something like that. The further up we go, the more later they become. So now this one says, given that log base 2 of p minus log base 2 of 32 is equal to -3, and log base 2 of q minus log base 2 of p is also -3, evaluate p and q. How do you think we can solve this? So what are you thinking for this one?
Oh, sorry, I was muted. Equate the first one, log 2p minus log 2 base 32 to log 2q minus log 2p, since they're both equal.
Oh, you want to equate them?
Yes, sir.
Oh, I never thought of it that way. Nice. So you want to equate these two equations, but then would it give you p and q?
It might.
Might. Let's try it your way. So let's try it your way. So you're saying, since both of them is -3, we're going to say the log to base 2 of p minus log to base 2 of 32. And you're saying just equate it now to be log to base 2 of q minus log to base 2 of p. That's what you're saying, right? Since
Yes.
both are -3. All right, I love this. I like this different way of doing it. The first thing that was coming to me was just put this as 1, equate to -3, put the other one as 1 log, and equate it to -3. But let's see it this way. All right. All right, then what are you saying we're going to do next?
Okay, sir. Based off my thinking, we can either we can do one of no. So we'd have to bring around, so we'd end up getting rid of p. So we'd get rid of p on one side. So
you want to get rid of? Okay.
Yes, sir. So we'd have log base 2 32 is equal to log base 2 of q.
Okay, so you just want to bring over this over here and bring this over there.
Well, sir, you don't move one of them. You just move the log base 2 of p so that we get rid of it. Or you can move both of them and have it equal to 0.
Oh, so you're saying this right here. How are we going to move this?
So you just move it to the other side. So you get that.
So you get 2 of this now.
Oh, yes, you get 2 of that.
Okay, so let's do that. So you bring it over here to get 2. You get 2 log base 2 of p. Bring it over here, 2 log base 2 of p. Okay, bring over this now and you get
yes, sir.
log
base 2 of q plus log
base 2 of q plus
log base 2 of 32.
Yeah, but what's log base 2 of 32?
That's the question. Let me go to the calculator. I know this. Wait. Sir, is it 5?
Yeah, that's 5. That's 5.
5.
Yeah, because we can rewrite 32 as 2 to the 5th.
Yes, sir.
Yeah, so this is 5. Log to base 2 of 32 is 5.
Yes,
so
sir.
So now right here, right, we can just say, okay, this part right here is now log base 2 of q
plus 5.
Plus 5. Alright? And now what I'm going to do is, since we have this now, I'm going to bring up the 2 and write it as log base 2 of p squared.
Yes, sir.
All right, nice. So if I were to bring over the q over here, I would get log to base 2 of, now since we're subtracting when we bring it over here, it would just become p squared over q, right?
Yes, sir.
P squared over q, and that's equal to 5. Now this is why I didn't want to do it this way, because look, now all we end up with is one equation with two unknowns, right?
Yes, sir.
Now from the start right here, if we were to just equate this side, right, we'd have gotten one equation with two unknowns, and then we equate this side, we get another equation with two unknowns, then we can solve them simultaneously. So doing it, that's why I was saying equating them, that would already eliminate one equation, all right?
Yes, sir.
And so this is fine to do it, but then you would still have to go back to one of these equations to help you to solve it, all right? So let's now just stick with the original equations, all right?
Yes, sir.
So this is fine as well, this is fine, but sticking with the original equations would have allowed us to get two equations now, but I like how you're thinking. Okay, since both of them is -3, why not equate them? I love that thinking, I love that, all right, because that is very useful. Just not in this case. Anytime they give us a log equation with two variables, two unknowns to solve for, always know it's going to be a simultaneous equation, all right?
Sir, you could solve them, but not simultaneously. Meaning, if you just solve for log base 2 of p, you can just use the value that you found for that into log base 2 of q without having to do it simultaneously, I think. Sir, because
so from right here.
Yes, sir. We know that log base 2 of 32 is 5. So you just say log base 2 of p minus 5 is equal to -3. Solve for p. And then...
All right, let's continue it. Continue it.
Yes, sir. You'd have the value of... Okay, wait.
So you're saying that log to base 2... Yeah, so let me hear what you're saying.
Sir, so log to base 2 of 3 is 32, right?
Log to base,
no, sir. A
different question. 2 of 32.
Yes, sir.
5.
5. Right,
so you're saying p squared over q is 32.
Yes, sir.
All right. So p squared over q is 32. Then what else now you're saying to me?
No, sir, that's not what I'm saying. We're starting over.
Okay. We're starting over?
Yes, sir. Starting over.
But this is fine as well, this is fine.
I know, but...
Yeah. All right, so let's underline this now in blue. Like from the equation in blue now, I'm not gonna trouble right here because I love how you were thinking, so I'm not gonna trouble that. Now in blue right here, log to base 2 of q minus log to base 2 of p, we can write them as one log equation. So I'm gonna write it in blue. In one log equation, that's log to base 2 of q minus p is q over p, right?
Yes, sir.
That's q, log to base 2 of q over p, and that's -3. All right, that's going to be -3. Now, if the log to base 2 of q over p is -3, then q over p is equal to 2 to the -3, right?
Yes, sir.
So q over p is equal to 2 to the -3, but 2 to the -3 is just, what's 2 to the -3?
2 to the -3 1 over... 2 to the -3 is 1 over 3. Negative?
1 over...
P?
So 2 to the -3 is 1 over 2 cubed. And 2 cubed 8. That's what I meant. And so we
Oh,
get one equation now by cross multiplying to say that 8q 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 is equal to p, right?
P. Yes, sir.
8q is equal to p. Now look at this. We don't even need to bother to use the second equation. I'm going to use this equation, and this equation that you created, I'm just going to substitute p as 8q. Right?
Yes, sir.
So let's punch in p as 8q right here. And so what we get is 8q squared. What's 8q squared?
8q squared.
Yeah.
So do we have a value for q?
Yeah, this 8q squared is just going to be 8 squared q squared. So 8q squared would be 64q squared.
Okay.
See that? Yeah, all we did was just square 8q. To square 8q, just 8 squared times q squared. So we get 64q squared over q is 32, right?
Yes, sir.
Now if we have 64q squared over q is 32, then what that is telling us is that 64q is 32, right?
Yes, sir.
So if 64q is 32, what is q?
If 64q is 32, then q is 32 divided by 64, which is a half.
Very good. So q is a half. So let's write that all the way right here. We're saying that q is a half. Nice. Now if q is a half, what is p?
If q is a half, then p.
And look at this. 8q is p. So 8 times a half
is 4.
and so p is 4. Nice. So that's it.
Sir, I think I got it another way though. There's another way to do it.
Okay.
Sir, if you just solve the first equation,
Yeah.
if you do log 2p minus log base 232 equal minus 3. Sir, if you just change log 232 to 5,
Yes.
and then bring
Very
it,
good. Yeah. Very good. Yeah,
you
that would
get
work
log base
a
2
lot.
of p,
Yes.
and you can solve for p and q from that.
Yeah. That's another method. I love that you're seeing that as well. So bring over this minus 5 over here to get 2. And then we have log to base 2 of p equals 4.
Yes, sir.
Right?
And you can use the log to base
Equal
2 of
4.
p.
Yeah.
Yeah, put it back into the first equation,
Very good.
in the second equation, and solve.
Nice. So we substitute the 4 here, bring it over, and we get 1 log to base 2 of q equal 1. And so we get that. Nice. I get what you say now, and we still get our same answers. All right?
Yes, sir.
Nice. Very good. Very good. All right? So we can clearly see that there are many ways to tackle the question, right? With log.
Yes, sir.
Many ways to do them. So that's part B. Now let's look at question 2. Now question 2 says, solve the equation log x plus 5 times the log of x plus 1 equal 2. And we're solving this equation for x. What are we going to do?
Okay, so well, first, can we distribute within the bracket? So you get log
Definitely.
5
Absolutely.
plus 5.
So we have 5x plus 5, right?
Yes, sir.
Yeah, so we just distribute in the bracket to get our 5x plus 5. So yeah, talk to me. What's the second thing that's coming to your mind?
Sir, since we have addition, would we just multiply them?
Oh, so you just want to use the law where we can just group them together. Log A plus log B is log AB.
Yes, sir.
All right, absolutely. You're fine as well. So x times 5x is 5.
5 squared
Yeah.
plus 5x.
Yeah, plus 5x. And that's equal to 2. So what's coming to your mind next now?
Sorry, then we do 5x squared plus 5x is equal to 10 raised to the power of 2.
Beautiful, beautiful. Nice, nice. Yes, I love that. I just love hearing when we're getting it so easy. Nice. So we say 5x squared plus 5x is equal to 10 square, and 10 square is 100. Nice. So what are you thinking of doing now?
Okay, sir. This is a simultaneous, not a simultaneous, polynomial.
Yes, this is just a
Quadratic.
quadratic.
Quadratic
Yeah.
equation. That word.
Yeah. Nice. So let's solve this quadratic. What I'm thinking of doing first when I get this.
Divide.
Very
Right.
good. Nice. Beautiful. Beautiful. You said it beautifully. Divide through 5. It's always difficult to solve with those big numbers. So it becomes x squared plus x. And let's bring over the 100 and write it as minus 100. All right?
Yes, sir.
That's equal to 0. Can we factorize this?
Yes. Maybe.
Let's check it out. Which two number, when we times them, we get negative 100, but when we add them, we get
Sir,
1.
negative 50.
Negative.
Sir, that's negative 50. Because, no, negative 100 divided by 5.
Oh, 20, 20. Thank you. Yeah, thank you. Because I was just saying, whoa, this number too big to split. Negative 20. So which two numbers that's thinking? Or with times them, we get negative 20. When we add them, we get 1.
4.
5 and 4?
Yes, sir. 4 and 5.
4
Negative
and
1, so or positive 1. So it'd be positive 5 and negative 4.
Yes, beautifully said. I couldn't have said it any better. Very good. Wonderful, wonderful. Sharp, sharp, sharp. Nice. And so what do we get for our answer? We get
X is equal to 4.
x equal 4.
Or X is equal to negative 5.
But what do you know? But x can't be negative 5.
Valid because
Very
you
good.
cannot log a negative number. At least.
Very good. So this one of negative 5, we're going to say inadmissible. It's not valid. Inadmissible. Alright? That one right there is not valid. That negative 5. Your answer is just 4. The negative 5 is inadmissible. That can't work, as we would say. Can't work. Nice. Very good. So let's look at part B now. What do you think we're going to tackle part B?
3 to the y plus 1.
3 to the y plus 1 equals 0.45.
Yes, sir. So, sir, we log them.
Log them straight away.
Not sure.
Like this to the this additional plus 1.
Oh yeah. So that's 3 to the y times 3 to the 1.
Very good. So we can say 3 to the y times 3 to the 1. And then what we can do next? We can divide both sides now by 3, don't it?
Yes, sir.
Very good. Very good. So now that we divide both sides by 3, now 3.45, we'll divide both sides by 3, we're just going to get the equation 3 to the y equals 0.15, right?
Yes, sir.
Nice. So what we're going to do now to find y?
Sir, would we log both sides?
Absolutely. Whenever the unknown is in the power, we log both sides. Beautiful. Beautiful, Ayana. Wonderfully said. So we log both sides. So we log both sides, we're going to get y log 3. Because we can bring down the power. Y log 3 is?
The y log 0.15.
Absolutely. Yep. So what we get now when we divide?
When we divide.
Yeah, to get y now, what's y gonna be?
Oh, y would be log 0.15 divided by log 3.
Yeah, and what to get in?
So hold on. Divided by log 3. We get negative 1.73.
Negative
7.
1.73.
Yes, sir. So
That sounds like minus root 3.
sir, it's a long number, 1.726833028.
Okay, it sounds like minus root 3. Nice. Now what we can do to check it back is put in the calculator negative 1.73 plus 1. That's going to give us
0.5.
That's going to give us 1. That's what, 0.73? And so 3 raised to the minus 0.73. Check it out. What is 3?
1.73, sir.
Repeat.
Negative 1.73.
Yeah,
So
what's saying?
0.1494. So it's close. So it's because we rounded up.
Yep. Very good. So we're good. Nice. Easy and soft. When you get this question, you write soft. And this is how I want you to write soft. I want you to write S-O-F when you put a capital T so that the pronunciation is made soft. You have to pronounce the T. Soft.
Yes, sir.
Like capital T. Alright?
Yes,
Nice.
sir.
Now here's another log equation like the first question that we're going to do. Tell me what's coming to your mind. What should we do?
Group all the logs on one side.
Very good. So let's bring it over. So we bring it over. We end up with now log to base 10 of x plus 5. And we bring it over. So we get plus log 10 of x. And that's equal to 2. So talk to me now. What's the second thing that's coming to your mind?
Multiply.
Multiply, what do you mean?
Sir, because we have addition, we're
Very
gonna...
good. So use that law. So we're gonna write them together as one log by using log A plus log B is the log of AB. So we multiply them, what are we getting?
We'll get x squared plus 5x.
X squared plus 5x
is equal to negative.
Is
equal to 2.
Absolutely right. Yeah. So what we do next?
What we do next, we do x squared plus 5x is equal to 2 raised to the 10.
Very good. So x squared plus 5x is equal to 2 raised to the 10. 2 raised to the 10 or 10 squared?
10 raised to the 2, 10 squared.
10 squared, very good. 10 squared, so that's 10 squared, which is 100. You are absolutely right. So now what we do now? Solve the quadratic, right?
Yes, sir.
So now which two numbers, we'll multiply them, we're going to get negative 100. But when we add them, we're going to get 5.
1. Sir.
Yeah.
Is there one?
All right. So anytime we're having difficulty in solving these equations, just go straight to quadratic formula. All right. And quadratic formula would be b minus b plus or minus that. So first, I'm just checking if there's a possible answer. So 5 squared minus 4 times 1 times negative 100. All right, so yes, it cannot be factorized, so we have to go straight to quadratic formula. Once we get to here, straight to quadratic. So this question we go straight to quadratic. So we're saying that x is minus b. X is now minus b, which is negative 5, plus or minus the square root of b squared minus 4ac over 2a. So it's plus or minus 5 squared is 25.
Yes.
Minus 4 times negative 100, that looks like 425. It's negative 5 plus or minus 425 over 2. Now let's use our skills that we learned in Surds now. And so we can break down 425 as something times 5.
Yes, sir.
So that would be...
Sir, the calculator says 5 root 17.
5 root 17? Absolutely, 5 root 17. All right, whoa, your calculator, what kind of calculator you have?
Sir, the FX, the Casio FX.
Oh, yeah, the Casio FX, nice. Those are the perfect ones. All right, so x is now minus 5 plus, that's 5 root 17, right?
Yes, sir.
Yep, 5 root 17. 5 root 17 over 2. Tell me why I can throw away the minus 1. Notice I throw away the plus or minus sign. Why can I throw away the minus 1?
Sir, because the log of the x cannot be negative.
The negative, very good. So now what would be this in decimal?
That entire thing?
Yes.
Negative 5 plus 5 root 17 over 2 is equal to 7.81.
Very good, 7.8. Now look what I want to do. In your calculator, when you get decimal answers, you always want to check that they're right. What I want you to do is check the log of 7.8 plus 5, that's the log of 12.2. To work out what's the log of 12.2.
So the log of...
Wait, 7.8 plus 5, that's not 12.2, that's 12.8.
12.8.
Yeah, work out the log of 12.8.
1.1.
1.1. And now check out what is 2 minus the log of 7.8.
2 minus log of 7.8. 1.1.
Beautiful. So now you know that we are correct, all right?
Yes, sir.
Anytime you get a decimal or something like that, you just want to check it to make sure. Check it to make sure the equation is satisfied. All right? Nice.
Yes, sir.
Okay. All right. We're doing so much log question. I want to see a third or something. All right, here's a different style of question. It says the curve is y is equal to px minus 15, and it passes through the point 2 and 25, and 3 and 20. Find the values of p and q. How are we going to do this? What's coming to your mind?
Sir, logs. Sir, because we don't know the value of... So are we going to log the equation? Log both sides?
All right. Now look at this.
Or sir, because we know the value of 1 x and 1 y, we're going to sub it into the equation.
Very good. Very good. So we can just write down, they're giving us when x is 2 and y is 25. So what we can just say is, okay, when x equals 2 and y equals 25, what we're getting is, clearly what we're getting now is, when we plug x as 2 right here and y as 25, we're getting 25 is equal to, that looks like p times 2 to the q p times 2 to the q minus 15. Absolutely. So that's one equation, right?
Yes, sir.
So it looks like we're going to have a simultaneous equation. And then the second thing we do, we're just going to plug in when x is 3. So we're going to say when x is 3, let's see what happened. When x is 3, what is y?
When x is 3, y is 20.
Y is 20. So since y is 20, what we can do is say, okay, we're going to plug 20 here now, and 20 is equal to, that looks like p times 3 to the q, right?
Yes, sir.
Minus 15. Now look what we're going to do now. We're going to call this equation 1 and this equation 2. We're going to divide this equation 1 by this equation 2. You're going to wonder why I'm doing that, but let's look at this. If I were to divide these two equations, well, I don't want to divide them yet. I don't want to divide them yet. We're going to divide them eventually, but let's simplify this equation first.
Yes, sir.
So bring over the 15 and we get 40, right?
Yes, sir.
Add 15 to both sides to get 40 is p times 2 to the q. That was what we needed to do first. Now that looks good. And then secondly, we can say, oh, all right, we're having so much fun, so let's do the same for when y is 20. So we say 20 is equal to p times 3 to the q. P times 3 to the q minus 15, yeah? And then we bring over, absolutely. And so 35 is 3 times 3 to the q, don't it?
Yes, sir.
35 is p times 3 to the q. Now, what we can do now is divide the equations. Let's divide them now. Let's say we're going to divide this part now. If I were to divide the 35p times 3 to the q by 40.
Sir, you'd get 2. Sir, what?
I'm dividing it by 40 equals p to the 2q.
Okay, sir, I was doing it out of your
Oh, okay, yeah, it doesn't matter the order, don't matter. Yeah.
Sir, so you'd get 3q over 2q is equal to 35 over 40.
All right, and 35 over 40, I'm just going to simplify it to be 7 over 8.
Yes, sir.
All right.
You get 2 over 3 raised to the power of q is equal to 7 over 8.
2 over 3 or 3 over 2?
3 over 2 raised to the power of q is equal to 7 over 8.
Exactly, beautiful. 3 over 2 raised to the power of q equal to 7 over 8. So we're going to get q now.
So we're going to log them?
Beautifully said, beautiful. So let's do it in a box right here. We're going to log both sides. So what's the log of 7 over 8?
The log of 7 over 8 is negative 0.06.
Negative 0.06?
Yes, sir.
And that's going to be equal to q times the log of 3 over 2. Q times the log of 3 over 2. Or as we can say, the log of 1.5. So now q, we just need to divide both sides by the log of 1.5. We're going to get that q is equal to negative 0.06 over the log of 1.5. So when you divide negative 0.06 to the log of 1.5, what you get?
Negative 0.06 divided by log of 1.5 is equal to negative 0.34.
Negative 0.34?
Yes, sir.
We're getting q is negative 0.34. Q is negative 0.34. Now, how are we going to get P now?
Sir, P.
Yeah.
So we didn't use one of the equations.
Beautiful. So we can use any one of these two up here. So what we're
Yes.
going to do is plug Q as negative 0.34. So 2 raised to the negative 0.34 is what?
The 2Q, 2 raised to the negative 0.34 is equal to 0.79.
0.79. Let's just say 0.8. And so what we're saying is 0.8p is 40. So what's p? 0.8p is 40. That's what we're saying.
Sir, P is 50.
P is 50. Nice. So we end up get P is 50. Now look what I want to do before you finish. When you get some decimal, decimal is always weird. So we always check back our answer. So let's put this in our calculator now. 50 times, when x is 2, is 50 times 2 to the q minus 15. We should get 25, right?
Yes, sir.
Let's check it out. So y is 50 times x is 2 raised to negative 0.34 minus 15. What are you getting?
Sir, 50 times 2 raised to the negative 0.34. Because I got something different.
Yeah.
Minus 15 is equal to 24.5.
All right, very good. So the answer is right. The only why it's not accurate is because we converted it to decimal right here.
Yes, sir.
I leave it as this log of 7 over 8. It works out to be minus 1 over 3. Getting the minus 1 over 3 will give us the exact answer. Right?
Yes.
Nice. So that's how we do that question. Easy, easy, easy. Soft. Alright, so tell them again, soft. Logs is too easy. When you get log question, you say soft. Capital P. Right? Nice.
Yes.
Alright, now let's tackle this one now. This looks a little bit different. It says 3 to the 2x minus 3 to the x plus 1 minus 10 equals 0. What's coming to your mind?
So we do the same thing that we did for the last one, which is split up the 3x plus 1.
Absolutely.
Sir, this is going to give a quadratic equation. I remember this question.
Beautiful. Well done. So this is a hidden quadratic. So they're trying to hide the quadratic by using indices. But we know our laws of indices, so we can write 3 to the 2x, we can rewrite that as 3 to the x squared. Yeah, absolutely. 3 to the x squared. And then we're going to take out this as minus. Now 3 to the 1 is 3. So we're just going to write it as 3 times 3 to the x minus 10. That's equal to 0, right?
Yes, sir.
Absolutely. So that's just a hidden quadratic. Hidden quadratic, so easy. So let's just go ahead and factorize. Now, a lot of persons are going to teach us to call 3 to the x y. Now, I don't like that. Calling 3 to the x, where that y come from, dummy variable. Let's just do it normally. The only way to get 3 to the x square right here means we're multiplying 3 to the x and 3 to the x, don't it?
Yes, sir.
That's the only way we can get 3 to the x squared. Now to get 10 means we're multiplying 5 and 2.
Sir. Yes, sir.
Absolutely. Now for it to be negative, yeah, go ahead.
So I was saying 3. Okay, never mind. I see why.
All right. Now the only way it can be negative 10 is if this 5 is negative and this one is positive. That's how we would split that. All right?
Yes, sir.
Now, once we get to this stage, this part won't have no solution. The part that's going to give us 3 to the x equal negative 2, that won't have no solution, right?
Yes, sir.
Because 3 to the x equal negative 2, that don't make no sense. So we're going to write not valid, NV, not valid. This is not valid. How can this happen? Right, that can never happen. So now all we need to focus on now is when 3 to the x is 5. If 3 to the x equals 5, what is x?
If 3 to the x is equal to 5, then you'd have to log it.
Very good, log it. So let's log it. So we get x log 3 is equal to log 5. So what's x?
Well, x is equal to log 5 over log 3.
Very good. X is log 5 over log 3. And when you put that in a calculator, what you get?
You get 1.46.
1.46. Beautiful. 1.46. You are absolutely right. Magnificent. Wonderful. Nice. Alright? Nice. Although we not book on no Surds questions yet. Let's see if we see a Surds.
Y equal, so root y is equal to log base 2 of root x.
You're saying root what?
Log base 2 of root x.
Alright, now what I do before I would substitute is right here what it is log root x. What I'm going to do is I'm going to rewrite
log x to the half.
Exactly. Nice. Now after I rewrite it as log to base 2 of x to the half, then I can just carry down the power. I can carry down the power to say that it is equal to bring down the half, and so this becomes a half log to base 2 of x. Right?
Yes, sir.
Now log to base 2 of y we can substitute as y. Right?
So root y is equal to half y.
Very good. So root y equal half y. It don't look so righted, but when it don't look so righted, what do? We square both sides. Root y equal half y, not 1 over y, half y. Whenever it don't look righted, square both sides. The square we get rid of the complication. Alright, so let's bring it up here. So we square both sides to get one square root. When we square root of y, what we get?
We need y.
So we square it, we get y, absolutely. And then when we square half y, what we get?
1 over 4y. 1 over 4y squared.
Y squared, beautiful. So we get y squared over 4. Alright? What do we do next?
We get, we multiply 4y is equal to squared.
Very good. So we bring over cross multiply to get 4y equals y squared.
So we bring over cross multiply to get 4y.
And then we can carry over the y squared. And that's equal to 0, right?
Yes, sir.
Then we can factorize out y. And so what we're getting is 4 minus y times y equals 0, don't it?
Yes, sir.
And so if y equals 0 and 4 minus y equals 0, what's the value for y?
4 or 0.
Y equals 0 or y equals 4. Beautiful. Alright. Now when we get these two values for y, look at this now. But what was y? Y was log to base 2 of x.
Yes, sir.
So we have log to base 2 of x is 0. And so what is x?
Sir, x is log to base 2 of 1.
If log to base 2 of x is 0, what's x?
1.
X is 1. Very good. X is indeed 1. So this is one answer. X is 1. And then our next answer is going to come from y equals 4. So y is 4. Log to base 2 of x is 4. So we have log to base 2 of x is 4. So if log to base 2 of x is 4, what's x?
16.
2 to the 4 is indeed 16. Very good. So x is 16. Brilliant. Now I can tell you that this year, you see this question, when it came on Cape, only 3% of the Caribbean got this question right. 3%. Right? Yeah.
Oh no.
3%. So all right, so that the trick right here was that most people didn't recognize they could rewrite the root x as x to the half. Imagine just that alone throwed off the question. All right? All right, let's close with this one now. All right? So we have the root of 11 plus the root of 7. It says show that it's equal to 4 over root 11 minus root 7. How are we going to do that?
Multiply across.
What do you mean multiply across?
Sir, we would multiply 11 plus root 7 by root 11 minus root 7. So sir, we would end up with difference of 2 squares.
All right, so we're going to multiply by 11 minus root 7. We're going to also multiply by the denominator as well. Remember, always multiply the numerator and the denominator by the conjugate. So 11 plus root 7, think of it as over 1. All right? Then we're going to multiply it by the root of 11 minus the root of 7. Very good. Now the numerator becomes the difference of 2 squared, right?
Yes, sir.
Absolutely. So then the difference of 2 squared becomes a squared, and root 11 squared is what?
11
minus root 7 squared,
4.
gives us 7. So it becomes 11 minus 7 over 1 times our root 11 over root 7. Well, that's just root 11 over root 7. And as you said, 11 minus 7 is 4. Nice. Easy, don't it? So the only little trick that they did with this question this year, this was 1998 or something like that. The trick was a lot of people didn't put it over 1. And so they just multiplied it by root 11 minus root 7. We have to always remember that all integers and all numbers by itself is really being divided by 1. So every number 4 is really 4 divided by 1. All right?